Welcome to this presentation. In this presentation, we're going to discuss database machine learning with Oracle database and Oracle Autonomous database. Just a quick introduction about myself. I work with DELL technology. I'm responsible for DELL EMC database solution engineering. I have been in industry for over 28 years. Specializing Oracle database, as well as the infrastructure that runs Oracle database, including the server, networking, storage, operating system, virtualized environment, and the cloud environment. Last few years, I also spent some time learning, exploring the AI machine learning emerging technology area. In the last 15 years, I've been the frequent speaker in all kinds of Oracle conference, as well as IEEE conference, some IEEE conference. So I have been Oracle ACE Director community since 2010. So I'm also keep my own personal Oracle blog. That is blog address. You can search my blog by going to Google. My name, Caillou, and DELL or Oracle. Recently, I co-authored this machine learning for Oracle database professionals, A+ book. This book can be used as a reference for this presentation. So in today's topic, we're going to discuss how we can use machine learning to enable some of our traditional business application, and what are the challenges. Then we'll take a look at how Oracle database can help to meet these challenges. And more specifically, we'll look at the Oracle machine learning environment coming with Oracle Autonomous database. And we're going to use a small example to show how to build a machine learning project with the Oracle machine learning in Oracle Autonomous data warehouse environment. Before we explore the machine learning for the traditional business application, let's take a look at a very simple traditional application. This application is designed to take customer mortgage request and also make a decision about whether or not to approve the customer mortgage request. So the business flow is quite simple. Customer provided mortgage request. Then the application take customer information and go to customer information database to search the customer credit score. And after returning the credit score from the customer information database, we're going to use this credit score to make a decision about whether or not to approve the mortgage request. So this application flow works well for the customer that we actually know the credit score. But what about for the new customer that we don't know the credit score? This business flow will not work. To solve this problem, we have to introduce some intelligent business process to the traditional business application. Instead of having using the credit score, we have to predict the credit score based on the other customer information, such as financial information, such as customer income, customer bank balance, and what kind of job a customer is doing, such other information. So in order to predict the customer credit score, we have to introduce some intelligent capability to predict the credit score. So the one method is to build a machine learning model that use the existing customer credit score to build a model. Then we can use this model to predict the customer credit score for the customer that we don't know the credit score. So the new flow will be, first we'll build such a model that we can predict the customer credit score. Then for the new customer, we're going to apply this model to the new customer and predict the customer how the make some prediction about the customer credit score. Then use this prediction to make decision about whether or not to approve customer mortgage request. So this is just an example to show that how we can use some AI machine learning functionality to expand the traditional business application. So we want to. The idea is to use some existing data to actually build a model to make to find more information from the business data. So according to a recent Oracle survey, 84% of organizations saying that they are going to use at least one of the emerging technology, AI, IoT, such as digital assistant, blockchain, to actually improve traditional business application. Some of the area are finance or supply chains. So this is a survey. This is a link of the survey. So this actually process to use the historical data or use the current data to find more business insight is not just started today. Since we have a transaction database, we already have business data. We already started build a report, a dashboard for reporting, and then we also use those data to do further diagnostic analysis report. And right now we are moving one step further to use the historical data to predict the future. So that is using machine learning for the prediction. And also once we have machine learning model, we also want to embed this machine learning model into traditional business process. For example, the one we just discussed. So we want to embed it in machine learning capability into this existing business process to expand the business existing traditional application. So some of a typical business problem that may involve machine learning are like including pattern discovery, prediction, we just discussed, grouping and actionable information, such as like make some action decision, such as whether or not we approve a customer mortgage request or approve customer credit card application. So those are the typical machine learning, the business problem that we use machine learning. And the machine learning also can be include two big categories. Supervised learning basically is based on the a set of non-data. So for example, in the credit scoring example, we will use a set of a customer that has the existing credit score information as well as other financial information. By using those existing data, we can build a model to establish the target value as a function of a set of independent attributes, such as customer income, customer bank balance, and customer job status, based on the non-data set. So the one that the customer credit information modeling, customer credit score machine learning model is a typical supervised learning function. So, and unlike supervised learning, unsupervised learning is not based on the non-data. We don't have such data. We don't have the data that with target value, but we still need to build a training model, build a model. Some of the example are anomaly detection. So for example, based on customer sales purchase information, we'll find some pattern that for certain customer, they buy certain things. Maybe there's a set of customer that behave differently. So this is just example. Association rule or clustering or future extraction, those are the typical supervised learning function. So let's come back to think about the machine learning for traditional business state application. So for this type of machine learning, we are using the transaction data. So usually those data are coming from transaction application, and there's huge data set that we need to use to build a model. And those data are actually structured data, actually stored in a table, not like the typical machine learning functions such as image recognition or voice recognition. Those are based on a picture or based on voice or even the text um, language recognition. So the data here is structured data. And so as a result, the tool that we use to do data exploration, data preparation might be different because we have to handle the structured data. So we need to have a tool to handle structured data. And a lot of time, the data we use for auto training needs to be real time because we also have a transaction database, transaction application that is going on real time to make it real time data. We want to be able to leverage those real time data to get a more accurate result. And also, we just discussed the machine learning model. Once we build a model, we want to be able to embed the model deployment into traditional application. So let's take a look at how Oracle in-database machine learning can help. So the idea for Oracle in-database machine learning is we do machine learning inside of a database. That's where the data is stored. Instead of you moving the huge data set from your data source to different machine learning platform. So this basically you skip or minimize or eliminate a huge data copy, because in very typical case we could have 100 gig or even maybe many terabyte data that we need to use. If we have to move data, it's very costly. So, but in order for us to be able to do machine learning, we need to have a machine learning algorithm. So the idea is Oracle is gonna put all the machine learning algorithm function into database so that we can use database as platform to build a model, to apply model, to validate the model. And also you can use the Oracle database to do the data preparation, data exploration. So we're going to use the database as a machine learning platform to do all the machine learning steps. So Oracle already did that. So they embedded about 30 algorithm into the Oracle database engine, and they pretty much cover all the basic typical machine learning function. So yeah, so those functions are built inside Oracle database engine, and support both supervised learning and unsupervised learning, and pretty much cover all the typical function. Yeah, and we can use SQL select tool or select statement to do all the preparation. Select view can leverage all the database tool to process data, and also the database itself is built in such a way that we can do all the steps of a machine, support the entire machine learning process, from data preparation to model training, model evaluation, model scoring, and the model deployment. So this is actually the list of all the machine learning functionality that embedded in Oracle database. So those algorithms actually can be used by simple SQL statement. So you don't have to use other language to call this function. Just use a simple SQL function, SQL statement to call. So you will be able to access all those algorithms to finish the entire process of machine learning. And another advantage is you can take advantage of the parallelism that built in Oracle database, because Oracle database is very famous for parallel query, and that can run multiple CPU, even cross the multiple node. So this gives you very fast, scalable solution. and also, of course, we don't have to move data. And also that once you build a model, the model will be stored into a database as a table. So this allows us to move your model around across a different database. Let's say you build a model in one database in your central data center. Then you can actually export the model into all department application. Those can be in different location. Maybe you can just do export. So you can have so far you can have a notebook or SQL interface to access all the machine learning functionality, no matter it's in regular database or your autonomous database. So this is just an example to show how actually you call machine learning algorithm. So all the machine learning algorithm is actually building as a function, is actually building under this called DBMS data mining package. So this is actually the one of the package that has many different procedures or functions that are designed to support Oracle machine learning. And once you build this model, this machine learning model will be stored into this table. This is actually table, just plain relational database table. Then once you have this model, you actually can apply this model to a specific customer by simply use this query. So this query will apply this model to a specific customer that has those attribute value. And as a return of this query, we will get a prediction of the credit score. So instead of getting actually the absolute value of a credit score, this query will get a prediction of a probability that this customer may have high credit score, such a threshold. So, and this is very simple, just query. If you have the right Python or other language code to do data modeling building or data modeling scoring, you have to write a much longer code. But this is very simple. And also, as database professional, Oracle, no matter you are DBA or developer, pretty much everyone is familiar with this syntax. So yeah, so SQL language is just one language. For those people who feel more comfortable with Python or R, you also can do that too, because a lot of data scientist people, they actually more familiar with Python. So they can use R or Python, but they still can call all the machine learning functionality inside Oracle database. And in additional to the actual script or language, you also can use GUI, which is very important because when you do data exploration, data preparation, you need to be able to actually look at data in a different way. The GUI environment give you such a way to do that. So you can use a machine learning notebook and or data mining user interface. And also more recently, the AutoML user interface is the one that 21C introduced. We're going to discuss a little bit more later on. And this environment actually supported entire machine learning process. So yeah. So, and all this are available for regular database as well as the Oracle Autonomous Database. Yeah, so 21C introduced some new features, new algorithm, such as these two algorithms, and also make some more optimization on the neural network algorithm. And another important new feature is a complete support of Python, the implement called AutoML for Python. So you can write all your Python code that call all the Oracle machine learning packages inside Oracle database. And one of the most important 21C feature is something called AutoML. As we know, if you want to build a machine learning model, you have to think about what algorithm machine learning algorithm you're going to use, how you sample data, how you select the most important feature to build your model, and how to provide the proper value for all those hyperparameter for all those machine learning parameter setting. All those selection, if you do manually, it's going to be very difficult, very long time, tedious process. You have to iterate many times because all this decision, all these different phase, each of them has huge impact on your model accuracy. So you need to find the best combination of all those selection. And for manual process, it's very difficult, very time consuming. So AutoML is trying to automate this process. Oracle will handle this for you. So you can focus on more business side instead of do all the tedious optimization work. So let's take a look at that specifically in the Oracle autonomous database environment, how we can do machine learning in this environment. So Oracle autonomous database is actually Oracle public database offering running in OCI infrastructure. And it has 3 different flavors, data warehouse, transaction processing, JSON. And Oracle machine learning is supported in all of these 3 deployments. And you actually can run 21C, currently is available in autonomous database. So once you create a autonomous database service, so you can sign on yourself to the Oracle autonomous database environment. Then you can provision a database instance, either can be data warehouse or transaction processing or JSON database. Once you provision a database instance, you're not just getting a database instance, you actually get an entire development environment that is associated with the database instance. So the middle one is actually the auto environment that direct link to your database instance. It is available immediately after you provision this database. Specifically, we want to talk about machine learning. This is one of the tool that we want to use for machine learning purpose. The product name is called Oracle Machine Learning. It's actually based on the notebook. Zeppelin notebook is actually is an open source tool, but Oracle take that Zeppelin notebook and customize that and put in link into your Oracle autonomous database environment that allow you to do all the machine learning scripting network or running environment or even GUI environment. So this is a web-based application. Once you have a machine learning Oracle autonomous database, you have the web access to this database, this environment, and it is building for different background people, data scientists, developer, Oracle DBA. You will find it easy to use. It's very high efficient, and because also it's actually backend is connected to your autonomous database environment. It also has GUI interface. It have direct access to all the database machine learning algorithm and function building inside of autonomous database environment. So all the machine learning algorithm API is accessible. So yeah, it's very similar. So if you're running Oracle machine learning from the autonomous database, you have access to all this functionality, which is very similar to your regular Oracle database instance, plus additional one that is a notebook. So you don't, if you run your your own database in your own environment, you have to do the open source notebook, which you have to do in some integration. But here in Oracle autonomous database environment, the integration is already there. So once you start up the database instance, you can access to the machine learning notebook. Then you can write the code, and you can execute the code. The code will be executed in the Oracle database environment. So here is once you create a database instance, you can come to this database instance admin page to create your user, manage your Oracle machine learning user, create a user for yourself. So create a user for yourself, then give a username, password, then go to this login page logging yourself into this Oracle Machine Learning main page. So this is the main page. This main page is direct connect to your Oracle Autonomous Database environment. So, and your Autonomous Database environment is your runtime engine to run all your machine learning algorithm or programs. So you can click either of them to do some more exploration. And the thing I want to recommend is, if you first time you come here, click this example. Once you click this example, you'll show all the basic examples. Totally, last time I checked is 54 example. The 54 example pretty much cover all different functionality, show you the example to how you write the code. And all those examples, the code is ready to run on your database. So you can just simply click run. The code will be can be run into your database, also bring the data to show you. So this is just, if you create a notebook, here's the notebook. So you can write the code here, then you can click this triangle to run it. And the result will be show up on the bottom. Default format of result is table. But if you change or click some of this button, they will give you different GUI display. So for example, once I create a pipe, the data will be displayed like a pipe. And also, I also can change the setting so that we can do some basic analytical function, statistical function. So I can do some statistics based on column. So I can drag those columns, put this box, so that I actually can do a lot of statistical calculation here. And the data will be shown right above this. So here's the calculation to basically kind of a group by certain value. So we see the data distribution by the value, one column value. So this is actually called a model job contract. So basically the type of job column, type of job, we can see the distribution of all the customer that in different job category. So let's quickly see the example to build a machine learning project with Oracle Machine Learning in our Oracle Autonomous Database environment. So this example you actually can get it from the example page. So this example basically will allow us to build, this is a small example that actually show you how to build a supervised learning model and how to apply the model. So this specifically, the data is actually the one big table, customer table. That table has all the customer information, income, or job information. And the last column is credit score. So it's actually range. So what the range you have. So this big fact table has non-data. So we know everything about this customer, including the credit score. Then we can use this non-data set to build a machine learning model to establish the function, the relationship of a credit score on rest of this column, sum of column. We want to build the function, the credit score as a function of this attributes. So the process to make this is actually two major processes. One, the first step is basically do some data analysis, prepare data, understand the data, and make data available for the machine learning, the model building. Then the second phase is to build a model on top of the data, and also verify that if the model is accurate. Then once you verify that, we can apply this model into new data set. So two major phases. Let's dive in a little deep on each phase. So first, prepare data. So we have bigger credit score table. We can, if you want it, we can make a, select, put into a view to prepare that data, 100,000 table, 100,000 row. Then we also, next step is we actually need to bin the table, bin the certain column. So for example, customer age, right? Customer income. So they all have, the value for those attributes is integer, specific integer could be, but we're not so care about the difference between the two close value. For example, credit score 101 to 102, make no difference. So instead we want to make a range. So for example, we have make 7 bins. So for credit score from 0 to 700, we make 7 bins. So each bin is ranged from 100. So from 0 to 100 is first bin, 100 to 200 is the second bin, so on. So, and once you create this bin, you can see the actually the data distribution on the each bins by using this query. Then next thing is we want to understand the attribute. What are the most important attributes that will impact the target value? So obviously we know for customer credit score, maybe customer income, customer bank balance, and a job, and the family status. Those are critical attributes. So we want to be able to find those important attributes. So this is actually the procedure to actually calculate it. This procedure will go to your sample data to do data analysis, find the top important attribute, and also then rank them. So once we finish that, you can actually rank top 6. So you can use a simple query to rank the top 6 attribute that is most important for your target value. Then before we are going to do the model training, we have to prepare the training data and the test data. So idea is we want to split the 60 or 40 split, and we want to make sure the split is random. So we're not going to say like first 60% a row in the beginning of the table, we put into test data, train data. The bottom 40% into test data. That's not a good way to do that. We're going to random pick. So this function called sample 60. This is a function to actually do the random pick. The random pick data divide is important, very important for accuracy of the modeling. Then we have to decide which machine learning model we're going to use. And also each model, they have hundreds of parameters. You know, maybe some of them small, like this one, we only have 6 parameters, but some may have more. But for each parameter, we have to give them value. That's where the manual process, the challenge for manual process. So we don't know this value. You have to use your previous knowledge to use the value as a first try. But if your first try is not working well, you have to use the second try to give a different value. So the AutoML will take care of this. But for now, we just do the manual. Just give them the number we already know. So then we build this model. We provide the model. We provide we get the data ready. We also get the setting ready. Now we just need to build a model by calling this store procedure. So this store procedure can be just executed in SQL+ or your notebook, either way. So now once you create a model, the model will be stored into this N1 class 1 table. Then we want to make sure that this model is accurate. So by apply this model into test data, so we know the test data is 40% of your non-data set. So those 40% non-data set, you actually know the credit score. But once you apply your model to those tables, you also calculate your estimated predicted credit score. So we're going to use the predicted credit score with real credit score to do comparison. That's how we actually can validate the accuracy of your model. But instead of calculating each one, so we actually call this function called compute lift mod function to actually get a final result. So we call this procedure. So we take this model, we use test data, we apply this test data, we apply the model, class model to this test data to get a result. Then we also calculate lift result. Lift result is actually single answer for us to show how accurate is this model. So we use this gain lift chart. So gain lift chart basically compare your calculated accuracy, the model accuracy with the real, absolute real value, which in test case, in test data, we know real value. And also compare with random. If we don't know anything, we just random guess what kind of data result. So we want to make sure that our estimated predicted value is close to the real value possible and far away from random value. So the more curved is this line is better. So that's how we actually evaluate data. Then if we agree that this model is good enough, then we can apply this model into new data. So you can apply the data, you can either apply the data to a single customer. So in this case, a single select statement will apply this model to calculate the probability of this customer that has good credit score. So this is just for single customer. But if you have a batch job that you one day you actually take about like 1,000 new customer, the end of the day you actually do the prediction calculation as a batch job to predict all the credit score for each of this new customer. So we can run this query, and also, or we can create based on this query to create a table. That table will take all the data from your new customer, plus add another column, which is called a prediction, credit score prediction, another column for each customer. We calculate prediction for each customer and put it into the column. So once you have this table, then you know the all new customer. I know the probability of each customer. Then we can simply use the probability to actually make a decision whether or not we want to take a credit score. We want to approve application. So this is kind of a process. For one customer, we apply this one customer. If you have 1,000 customers, same way we apply this model into 1,000 customers as batch job to get it, the prediction of the high credit score, and then we can make a decision for each customer whether or not we should give them approve the credit mortgage request. So this is just an example to show the business process and how we use the machine learning model. You can see that we use all the tool. This is the Oracle machine learning notebook tool. So yeah, that's the conclusion. We discuss how the machine learning basically will help, will add more intelligence to the traditional business application. And we also have, in order to do that, we have to meet some challenges and the Oracle in database machine learning is designed to meet those challenges. And also specifically Oracle machine learning in Oracle Autonomous Database, either ADW or ATP, they all offer the same environment. That's the Oracle machine learning environment based on notebook. You actually can write the code, run the code, also display code, display the result. You also can use this environment to finish the entire process of machine learning, from data analysis, data preparation, machine learning, model building, and model evaluation, and model deployment. So we use the example. So that's the thing I want to cover. If you have questions, you always can send me email. That's kai_yu@.com, or come to my Oracle blog. And so you can leave comment here. I also have all of my over 200 presentation that I ever have done since 2006. So you can download each of them from this blog. So that's all I want to cover, and thanks everyone for attending this session. I want to make sure that you have this session will be helpful. And if you want to get further information about this topic, this book might provide some additional information, especially if you want to know more about the machine learning model itself inside Oracle database. First 3 chapters, you can read it. If you want to understand all the machine learning pipeline, even more deep topic, more advanced topic, you can read the last 3 or 4 chapters. If you want to know more about the Oracle Autonomous Database machine learning, you can read middle 3 chapters. So totally this book has 10 chapters. So that's how to divide it. So I want to thank you everyone for your time to attend this session. And hopefully next year we can actually meet each other in the physical conference. We can discuss even more further. Yeah. Thank you.